Okay, we're going to look at Chapter 6, Section 1, which focuses on data and statistics. If you have not taken 111 yet, this is a good intro to 111. If you have taken it, it's probably going to sound pretty familiar. So what are statistics? Statistics really is the science of gathering and analyzing data. Okay. Gathering data and organizing it kind of lets us know what is going on, what has been happening. Inferential analyzing data tells us more about maybe what conclusions we can draw or maybe what might be happening as a trend. Okay, so the descriptive statistics, that's the part of statistics where we're gathering and organizing that data, in charts and graphs, other getting facts about the data. Whereas inferential statistics is where we're going to use that data to draw conclusions and ask it to tell us something. Most of the time, we're used to hearing number summaries like mean, median, and mode, the 3 M's. Okay, mean, of course, is just a mathematical average. You add all the values up and divide by the number of values we have. So if I had 5 unique digits, I would add them all up, divide by 5. That's my average or my mean. Most of us are used to thinking of our grades as a mathematical average. A median, of course, if we hear the word median, we kind of think of the middle of the road. That makes sense because this represents the value in the middle when the data is organized by value. So if I have a list of 21 digits, if I put them in order, doesn't really matter if I go bottom to top or top to bottom, then that middle number is going to be the median, okay, whatever winds up in the middle of the numbers. Mode is, of course, the value that happens most often. It's possible to have more than one mode. It's possible to have no mode. For example, if I had a list of 10 values and 3 of them were 0 and 3 of them were 5, and none of the others repeated, then my mode would be both 0 and 5. It is possible for me to have no mode. If I had the same list of 10 values and none of them repeated, I would have no mode. We talk about these as measures of center, okay, kind of where the middle of the data is. Most of the time, that's kind of what we want to know. Mean and median being where our focus usually lies. Median, most of the time, ends up being chosen as a better description of the center, mostly because it's not influenced by outliers. Okay, now if you don't know what outliers are numbers in a data set that are much bigger or smaller than the others. We see this all the time in our grades. For example, if you have to take 3 tests, you take 2 of them and get 98s or 99s, and then on the third test, for some reason, you end up with a 0, then that would be an example of an outlier, okay, much smaller than the rest of the data, and of course, it would bring your average way down. And your mean grade would no longer be very reflective of your typical performance, okay? That wouldn't happen with the median. Okay? The median is resistant to outliers, okay? So no matter where the top and the bottom are, how high or how low they are, the middle is still always going to be the middle. So that's a lot of times why median is chosen as a better descriptor of center. It's not influenced by those outliers. Okay, number 5 asks us, what are frequency tables and what do they tell us? Okay, frequency tables tell us how often some event or some result happened. So when you look at number 6, this is an example of a frequency table. Okay, what we've got here is the number of goals that were scored in a soccer game by either team, just added up the score. And then the bottom row tells us how many games that happened in. So it's a count of how often this was the total goals scored in a particular game. Okay, so this data pair right here means there were 5 games where there were no goals scored by either team. If we were to take this frequency table and we were to write this data out individually, I would have 5 zeros, 10 ones. Okay, that means there were 10 games where 1 goal was scored, 14 twos, and there were 14 games where 2 total goals were scored, 14 threes, 10 fours, 2 fives, 1 6, and 1 7. Okay, so a frequency table is just a little bit more organized way to represent data that is sometimes repetitive. Okay, now if I wanted the mean of this, I would add up all of this data, 5 zeros, 10 ones, 14 twos, 14 threes, and so forth. We get 143. And I would divide it by 57 because if you count the total number of games here, there were 57 games total, which means I end up with an average or a mean of about 2.5 goals scored per game, right? An average of that. A median, there's 57 values here, 57 games. So if I'm looking for the middle, okay, I know first of all that 57 is an odd number. Okay, so there has to be one single number in the center, not a pair. Okay, so what I'm going to do is I'm going to think about where might that number be. It ends up being the 29th value because if I look at the 29th value, I have 28 values below. I have 28 values above. That makes 56. Okay, and then the 29th one in the middle of that is your 57th. Okay, now I know that's 2. I could have done that by writing all this data out and just marking them off. High, low, high, low, high, low. I could have done that until I worked my way to the 29th value, which is the 2. That's one way to do it. I also could have just counted. Okay, I know that I have 5 values here in tenors. That's 15. Plus another 14 is 29, so that I know that 29th value has to be a 2. Okay, mode would be 2 and 3 because those are the 2 results that happen the most often. Okay, now what is a histogram? It's really just a chart-like representation of this frequency table. Okay, on the y-axis we have how frequent something occurs. On the x-axis we have the value or the result that we are counting. So this is just a quick sketch of this frequency table sort of in histogram format. The 0 result happened 5 times. The 1 result happened 10. The 2 and 3 happened 14. The 4 happened 10. The 5 happened twice. And then 6 and 7 goals happened once each. We're used to the 3 M's. That's pretty common. But we also talk a lot about the 5-number summary in statistics. What's in the 5-number summary and what does it tell us? Well, first of all, you've got the minimum and the max. Of course, that's the lowest and the highest values. We also have the median. Sometimes here you hear it called Q2. That just stands for the second quartile. The reason being, if you think of 2 quarters, you think of 50 cents. That is the middle of the data, the 50th percentile. Okay, now what are Q1 and Q3? They are the other 2 values of a 5-number summary, and they're called the lower quartile and the upper quartile. Okay, now why? Well, all of the quartiles together, Q1, Q2, and Q3, remember Q2 is the same as the median, they break the data up into 4 equal parts or quartiles. Okay, so how do we find these? First of all, I'm going to pretend like this 1 through 7 is my set of data. I'm easily going to mark off the min and the max. That's easy to find. And if I work my way, high, low, high, low, high, low, I see that I've got my Q2 or median here at 4. Okay. We always have to find the median or Q2 first, simply because it's hard to know what the middle of the bottom half is if we don't know what counts as the bottom. It's also hard to know where the middle of the top is if we don't know what counts as the top. Okay, so that's why we have to mark the median first. We have to define what is the bottom half and what is the top half. Once we do that, the median is not part of either half. It's in the middle. So in this case, I've got 1, 2, and 3 in the bottom half. I have 5, 6, and 7 in the top half. If I find the middle of the bottom half, that's Q1, which is 2. I find the middle of the top half, which is Q3.